Welcome back to this series of lectures on regular expressions, and this is part 1. We already know that we can actually search for substrings within a larger string with the in operator. Here's a very simple example. I could check if dog is within a larger string of text by saying the string dog in my dog is great. And in this case, it would return back true. Now we can already see this has severe limitations. We need to know the exact string we're looking for, and we need to perform additional operations to account for things like capitalization and punctuation. So what if we only want to search for a pattern structure of a string we're looking for? That is to say, what if we know that we're looking for an email, but we don't know the exact email we're looking for? We're just looking for all the emails within a document. Or we're looking for something like a phone number, where we know the general structure of the way a phone number is presented, but we don't actually know the exact phone number we're looking for. This is where regular expressions, or regex for short, allow us to search for general patterns in text data. For example, let's go back to that email. We know that a very simple email format could be something like user@email.com. And we know in this case, for this very particular domain, if I wanted to find all the emails within a very large document of text, I know I'm looking for some pattern of text@text.com. So essentially what we're looking for is what we don't actually know exactly or precisely. That is, I know there's going to be some text for the username, and I know there's some sort of domain name, and then I have the things that I'll assume I do know. In this case, I will assume that there's an @ in between the user and the domain, and in this case, I assume the domain name ends in .com. I know there's other domain names, .io, .xyz, etc. But for this particular pattern, let's say I'm only looking for emails that end in .com. So what I can use regular expressions for is to construct a generalized pattern to search for something like this. So Python comes with this built-in regular expressions library, or RE for short, and you import it as RE. And the RE library allows us to create specialized pattern strings and then search for matches within text. And the main point I want to get across right now is the primary skill set for understanding regular expressions is really understanding the special syntax for these pattern strings. And I don't want you to feel like you need to memorize all these patterns. Regular expressions are notoriously difficult to memorize and understand. What you should really focus on is understanding how to look up the necessary information so you can quickly find the appropriate or correct patterns. Especially if you don't use regular expressions that often, you won't find yourself memorizing these specialized syntax codes. Instead, understand how to convert what you're looking for into a specialized pattern syntax, and then you can look up the necessary patterns, quantifiers, or identifiers that you need. So here's a simple example of what a generalized regular expression could look like. Let's imagine I'm looking for a phone number, and I know that it's in this format somewhere within a very large document. I know it's going to have 3 numbers in parentheses, a dash, another set of 3 numbers, a dash, and then a set of 4 numbers. An example regular expression pattern could look like this. So let's focus on what's happening here. Notice that outside of the string, there's an R, and that basically informs Python, especially when you're using the regular expression library, that don't treat this as just a normal string. There's actually identifiers within this string. And you'll notice that there's a bunch of backslashes, which corresponds to the individual identifiers. So these identifiers are essentially just placeholders, almost like wildcards, waiting for a match based off a particular data type. And in this particular case, \d stands for digit. So this is essentially saying I'm looking for 3 digits in a row. It doesn't actually care what the digits are because we don't know what the digits are yet. We just know that they're going to be in this format. And then you'll notice the other strings that are present are the format strings themselves. I know there's going to be parentheses, I know there's going to be a dash, I know there's going to be another dash there. And those, you'll note, don't have a backslash associated with them because they're not an actual identifier for a regular expression. We're actually looking for that exact string. So again, we have these general identifiers and then the exact strings we're looking for. And this in turn constructs a general regular expression pattern. Now this is kind of the most simplified version of one. They can begin getting more complicated. You'll see here, this is a regular expression pattern that actually solves the exact same problem as the one before, but now it's using things like quantifiers in order to reduce the amount of text you actually have to write. So this is essentially saying find 3 digits in a row, and then another 3 digits, and then another 4 digits. And we're going to learn how to do this throughout this series of lectures. Okay, so we're going to start off first in this particular lecture is focusing on how to use the regular expression library to search for patterns within text. And then afterwards, we'll focus on understanding the actual regular expression syntax codes, those patterns that we just saw earlier, like \d, identifiers, qualifiers, groupings, and so on. Okay, let's get started. I'll open up a Jupyter notebook. Let's begin by understanding how to search for basic patterns. We'll create some example text saying something like, the agent's phone number is 408-555-1234. Call soon. As we just discussed, you could search for simple strings in the text, such as phone, in, text, and you would get back a Boolean indicating true or false is that actual string in the text. But now let's show the format for regular expressions. To do this, we will import the regular expressions module, RE, and then we'll assign the pattern phone to a variable called pattern. So we will say that the string phone is equal to pattern. Then we can say RE, call the search function off of the regular expressions module, and then you pass in the pattern, and then you pass in the text, and you get back this match object. And so notice how much more information is here. This match object will report back not just whether there was a match to the phone, but also where the actual index location spanned to. So it starts at index 12 and then ends at index 17. So now let's search for a pattern that we know is not in the text. So we'll create another pattern variable, or really overwrite it, and then something like not in text, which we know isn't there. And if we search for the new pattern in our text, we get back none, which means we don't really get back anything because there is no match. So now that we've seen that this re.search function will take the pattern, scan the text, and return a match object, and if no pattern is found, none is returned, which in the notebook setting just means that nothing is output to the cell. Let's take a closer look at this match object from before. We're going to reset pattern as phone, and we're going to run this search again. We'll say re.search pattern in the text, and we'll actually save this to the variable match so we can explore this match object. So this is a regular expression match object, and it has a lot of information that we can grab from it. We can call the span method in order to get the actual index location of the span. And then you could also ask for the start or the end index by themselves. And keep in mind, if we had multiple matches inside the string, we would unfortunately only get back the first match. So if I had a string that said my phone once, my phone twice, and then I tried running the same command as before, saying match re search for phone inside of this new text, and then I check the match itself, it only turns back one span, 3, 8, because that's the first match right here. If I want to find multiple matches or all the matches, I can use the findall function instead. So I can say matches is equal to re findall, and I will search for, again, phone in that text. And then if I check my matches, I get back this list of how many matches I had. So if we wanted to check how many matches there were, I could get the length of this list. And if I want to get back actual match objects, then I use the iterator. So to show you what I mean by that, I can say for match in re find, and instead of find all, I can say find iter, and then pass in whatever pattern I'm looking for. So I could be looking for phone again, and then pass in the text I want to search. And what this does is it iterates through this text and then returns each match object that's found. So just like before when we were using search, we returned back the first match object, essentially indicating where we first matched up. If we use find all, it just returns back a list of the strings themselves. If I want to kind of combine these two by iterating through the text object and then finding every single match object, I use find iter. So you're going to need to essentially use a for loop with this to iterate. So we're saying for match in re.findIter, you pass in the pattern and the text you want to search for, and then you can print out the actual match object, and then we get back the match objects. And you can do whatever you want with these match objects. For instance, if you were just interested in the spans, you could call the span method off of it, run that, and it will return back the spans. Now, if you wanted the actual text that matched, all you need to do is use the group method. So you could say here, group, and that returns back the actual text that matched up that you were searching for. Essentially what you get back when you use findall. So far, we've been able to realize the critical functions of the regular expressions module, and that is the search function, where again you just pass in a pattern and the text, and it returns back the first match object. The findall function, which again, pattern text, and it returns back just the list of matches indicating the strings that matched. And then the findIter, which is essentially a combination of these two, where you go through the entire string and you return back match objects for the actual pattern you're searching for in the text. Then you can call any methods you want off of that match object. What we haven't discussed yet is the actual special regular expression syntax for general patterns. Right now, we've only been searching for basic strings. Up next, we're going to discuss how to build these special identifying regular expression pattern codes. I'll see you at the next lecture.